Okay, so now that we've talked about what's due and when and all that stuff, let's take a look at this particular section right here. This is a really important chapter, and it's really important that you understand and take the time to think about why these problems work the way they do. If you do, you're going to be much better off in the rest of this course, especially in chapter 9. You're also going to be better off in 1050 and in 1060 because there's lots of graphing that takes place in those. And if you understand the basics of how we graph these and transform them, move them around, stretch them, shrink them, and stuff like that, you're going to be much better off. Okay, so if we think about this equation right here, that is a linear equation, and it's called what? Okay, it's called slope-intercept form of a linear equation. So we're going to graph this one right here. We're going to graph y equals 2x, and we're going to state what the slope is and what the intercept is. The slope is 2, and the intercept is 0. Okay, now here's the shape that it makes. When I plug in a 0, I get out a 0. When I plug in a 1, I get out a 2. When I plug in a 2, I get out a 4, and so forth. If I plug in a negative 1, I get out a negative 2. If I plug in a negative 2, I get out a negative 4. Whatever the number is that I plug in, it doubles it. If it was positive, it stays positive. If it's negative, it stays negative. So I get a line that looks something like this. Whatever the number is that I plug in, I just simply double it. So if I went over to 400, I'd go up to 800. If I went back to negative 10, I'd go down to negative 20. Okay? So that's the shape that that particular graph makes, and it's a graph that we're reasonably familiar with. Okay, but this is a really important idea. Every function makes a shape when you graph it. Okay, the shape is a picture of all the points that work in that function. Okay, and this particular chapter is about a special type of shape. It's one that comes up all the time. It comes from a function called a quadratic function. Okay, and a quadratic function is a polynomial that has a squared variable. So a lot of times you'll see it written like this. It'll say f of x equals ax squared plus bx plus c, where a is not equal to 0. So what this means is there aren't any cubes or fourths or anything like that. X squared is the highest power, and a is not equal to 0. So what that does is it guarantees us that the highest power is x squared and that there is a term of x squared. Now, we don't need any other plane x's or any other plane numbers to make sure it's a quadratic. In other words, both b and c could be 0. We could have just this. X squared technically is a quadratic. It meets the criteria. So that right there is a quadratic function. Okay? So these are used all the time. They have lots of different applications. And what we're going to start with is the basic graph of a quadratic. And what do we call this shape? We call it a parabola. Okay? Now, we're going to make this shape. If you've done these before, I don't care. I'd like you to think about them this way. Okay? We're going to cover the basics on the first page, and then we're not going to be making XY tables anymore. You better understand why this makes the shape it does, okay, and what that pattern is. So we're going to do a little XY table. This squares whatever we plug in. So if I plug in a negative 2, I square it, I get 4. There's a point on the graph. If I plug in a negative 1, it squares it, I get a 1. There's a point on the graph. If I plug in a 0, I get a 0. If I plug in a 1, I get a 1. And if I plug in a 2, I get out a 4. So let's graph this really carefully, and we're going to label these 5 key points. This is what we're going to call a parent graph. So 0, 0, 1, 1, 2, 4 on this side, negative 1, 1 here, negative 2, 4 here. So I've got 2, 4. I've got 1, 1. I've got 0, 0. I've got negative 1, negative 1, positive 1. And then I've got negative 2, 4. Okay, everybody watch, please. Need you to watch. Okay, we're going to connect these shapes in a nice smooth curve. So I'm going to go from here over to there. But a lot of people just do this. And then they stop right there. Is that right? No. Because I could go over to 3, and then if I plugged in a 3, I'd get a 9. So we'd want to extend this in both directions. It continues going up and out. This is the parent shape. This is our parent graph. This is the fundamental shape of a quadratic. This is a parabola. This is our basic parent parabola. Any questions? Okay, everybody watch. You can put your pencils down. I need you to think about this. This is why this function makes that shape, and this one, let me erase this. Oops. This one right here makes that shape. This has a 2 and an x in it, and this has a 2 and an x in it. But they make completely different shapes because of where these are and what the operation is. Here, all we're doing is taking whatever we plugged in and timesing it by 2, just doubling it. Here, when we plug something in, we square the entire thing. When we square something, it always becomes positive, right? So if I plug in a 0, I get 0, 0. Watch, please. If I go over 1, I'm going to go up 1 squared. If I go over 2, I'm going to go up 2 squared. That's going to put me on the graph. If I go over 3, I'm going to go up 3 squared, or that would be 9. Is everybody okay with that? Okay, now, when I started plugging in negative numbers over here, I went down to make points on the graph. Why doesn't that happen on this one? Why, when I go over to negative 1, what point did I get again? I got 1, right? Because I go over 1 and I go up 1 squared. Doesn't matter whether I go to the right or the left. When you square that horizontal distance, when you square 1, you get 1. What happens if I go over 2? Square that, I get 4. What if I went back 3? I'd go up to 9, okay? So what happens here is instead of the graph going down on this side, okay, the squaring makes it go up. And when I square a number, because it's being multiplied by itself, not always just multiplied by 2, it has this bend to it. It gets bigger faster. This gets big, but it gets big in a linear fashion. This gets bigger and bigger and bigger, faster and faster and faster. Okay, does that make sense? Okay, that's why it makes the shape that it does. So let's point out a couple key points about this shape. Okay, this is what we're going to call the quadratic pattern, or we're going to call this a parent graph for a quadratic. This point right here is called a vertex. That vertex is the very bottom point of the graph. So we've got a vertex. The vertex on this one is 0, 0. If we want to make this shape, from the vertex we go to the right 1 and we go up 1 squared. Again, starting from the vertex, if I go to the right 2, if I go over 2, I'd go up 2 squared. And then I repeat the pattern on the left. So if I go left 1, I go up 1 squared. If I go left 2, I go up 2 squared. Again, we go up because it's squared. And we figure out the distance by just squaring how far we went from the vertex. Okay? Any questions there? Okay, then we've got something else. You'll notice that this point here was 2, 4, and this one was negative 2, 4. This was 1, 1. This was negative 1, 1. We have what we call an axis of symmetry. Okay? So the right looks exactly the same as the left. Okay? So we've got this nice fold symmetry or reflective symmetry. On this one, the axis of symmetry is x equals 0. So the axis of symmetry is x equals 0. The parabola opens up, and the minimum value, meaning the minimum function value, the smallest the function gets is right here. That happens at the vertex. So we've got all these big points right here. Come down, come down, come down. Hit the lowest point right here at 0, 0, and then head back up. Okay? So we'll call this opening up, and we'll call that a minimum that occurs at the vertex. Okay, are there any questions? Okay, that is the basic shape. Okay, now we're going to make some adjustments to that basic shape. We're going to graph f of x equals x squared plus 1. So I'm going to plug in an x, and I'm going to get out an f of x. Now let's plug in negative 2, negative 1, 0, 1, and 2. If I plug in a negative 2, watch please, this is going to be important in just a second. What's the first thing we do to it? Square it. In other words, we make that parabola shape. Then I add 1 to it. Square negative 2, you get 4. Add 1, you get 5. Plug in a negative 1. Square that, you get 1. Add 1, you get 2. Plug in a 0. First thing that happens is we square it. Add 1, so we get a 1. Plug in a 1, you get a 1. Add a 1, you get 2. What am I going to get here? 5. Look at that nice pattern here. So if I graph 0, 1, so that's right here, and I graph 1, 2, and I graph 2, 5, and I graph negative 1, 2, and negative 2, 5, there's the shape. Here's what I want you to notice, and this is the important part. You with me? Okay, I need everybody's eyes up here. How are we doing there? Good.
I already saw the graph.
Excellent. Okay. This is the important part. Not that you can make the graph, but that you understand why it does what it does. Look at the vertex. If I go over 1, remember this is 0, 1. If I go over 1, that would put me at 1 for an x coordinate. And if I go up 1 from here, where do I get to? I get to 2. Start over at the vertex. If I go over 2, I'm going to go up 2 squared, so that's going to be up 4. So that's going to give me an x coordinate because I went over 2. Then I'm going to go up 4 from there, up 2 squared from there. If I was at 1 and I went up 4, where would that put me? That would put me at 5. Okay, now, I see some people thinking, you know, I already know how to do this. I've graphed this before, or gosh, I'm not quite sure what went on there. This is the key idea here. If you're not going to pay attention to this, or you're not going to put the effort in to figure this out, you are shooting yourself in the foot. You are making life more difficult. Because that vertex right there is a really important part on the graph. And I can make the rest of the shape using the same pattern that we did on the other one. So from the vertex, go over 1, up 1 squared. Over 2, up 2 squared. And then I can do the same on the other side. So if I back up 1 from 0, 1, if I go to the left 1, which coordinate will change? The 0 or the 1? The x or the y? The x will. That'll put me at negative 1. If I go up 1 from here, which is going to change? The x or the y? The y is. So I'm going to go to negative 1. Oops. And if I go back 2, I'm going to go up 4. If I go back 2 from here, I get negative 2. If I go up 4 from 1, I get 5. See how these points were on the graph? They were points that I found there. So you don't have to use an XY table to produce them. Okay, let's do this one right here. So we're going to plug in an x. I'm going to change colors. We're going to get out our f of x, and if I plug in a negative 2, a negative 1, a 0, a 1, a 2, if I plug in a negative 2, I get 4. Subtract 2, I get 2. Plug in a negative 1, I get 1. Subtract 2, I get negative 1. Plug in a 0, I get 0. Subtract 2, I get negative 2. And then I'm going to have negative 1 and 2. So here's 0, negative 2. Okay, everybody watch, please. Again, I'm interested in you being able to produce the graph, but to do it the right way and think of it the right way. This point is 1, negative 1. This point is 2, 2. That point right there is negative 1, negative 1. And this one's negative 2, 2. So I have exactly the same shape that we did before. It's just the vertex is down here. The vertex is at 0, negative 2. Okay, now watch. From the vertex, if I go over 1, that's going to change my x coordinate to a 1. If I go up 1 from negative 2, where does that put me? If I'm at negative 2 here, and I go up 1, that's going to put me at negative 1. Again, from the vertex. If I go over 2, that's going to make my x coordinate 2. And if I go up 4 from here, remember, over 2, up 2 squared, so we're going to go up 4. So if I go up 4 from negative 2, where does that put me? Puts me at 2. Can you see why these points are on the graph? Are there any questions? That's easy? Okay. So if y equals f of x plus k, or in other words, if we have our x squared here, our function that makes that shape, and then we add k, that's like this one right here. What happened to the shape and the pattern? Where did it go? Went up. Moves up k units. If we have our function that makes the shape and then we subtract k, what does it do to the graph? Like this one. Moves the exact same pattern down k units. So this one moved that shape up 1 unit, this one moved the same shape down 2 units. Any questions? Okay, let's take a look at the next one. This is different. Okay, need you to watch. If I plugged a -2 in here, what was the first thing that happened to it? It was squared. That makes that parabola shape. Then we just add 1 to it. That bumps it up 1. Something different happens here. If I plug these numbers in again, when I plug in a -2, what's the first thing I do to it? I add 1. Then I square. So if I plug in a -2, I add 1 to it. It acts like a -1. When I square it, I get 1. Plug in a -1. Add 1, I get 0. It acts like a 0, so 0 squared is 0. Plug in a 0. Add 1 to it. 1 squared is 1. Plug in a 1. That's going to give me a 4 when I'm done. Plug in a 2. That's going to give me what? Plug in a 2, add 1, I get a 3, square that. The end result is I get a 9. Now, let's graph these and notice that something different happens. I'm using the same points I did before, same x coordinates. I get -2 and 1s. Let me make this bigger so we can see what's going on here. -2 and 1, so we're right here. -1 and 0, 0, 1, 1 and 4, 2 and 9, so we're way up here. Is it still a parabola? Yeah. Okay, watch please. Need you to watch. From the vertex, I go over 1, up 1 squared. Over 2, up 2 squared. Over 3, up 3 squared. If this point was, -1, 0, if I go over 1, that makes this coordinate 0, and if I go up 1, 0, 1. Over 2, that makes this coordinate 1. If I went up 4 from 0, that would put me at 4. See how those points are on there? And if I went over 3, that would put me at 2, 9. Everybody okay with that? Okay, this point we already know what it is. Over 1, up 1 squared. What if I went over 2? What's my new x coordinate? Careful, over 2, -3. Up, how far? Up 2 squared. So this would be right here. So that would be the point -3, 4. This is what my graph looks like. Notice this point is on the graph. It better work if we plug it in. If I plug in a -3, the first thing I do to it is I add 1. This is important. I add 1 to it. So I've got a -2 here. It acts like it's a -2. Even though I plugged in a -3, I square that, I get 4. That's the right point. It comes from the pattern. Okay? Now, on this one, it moved the graph which way? To the left. Why did it move it to the left? Well, you'd think adding 1 would move it to the right? Okay, we'll talk about that again in just a second. Let's take a look at this one. Now, you'll notice where the vertex was on this. It occurred at -1. That's when this one acted like a 0. When would this one act like a 0? When would x minus 2 act like a 0? When x is +2. Okay, so I'm going to plug in 2. And I'm going to pick a couple points on either side. So I'm going to pick 1 and 0, and I'm going to pick 3 and 4. So if I plug in a 0, The first thing I do to it is I subtract 2 from it. So it's now acting like a negative 2. So square that, I get 4. Plug in a negative 1, or sorry, a 1, I get a negative 1. Square that, I get a, whoops, square that, I get a 1. Plug in a 2, I get 0. Plug in a 3, 1 squared is 1. Plug in a 4, subtract 2 from it, so it only acts like a 2, so that's going to be a 4. So let's graph this. So 0, 4, 1, 1, 2, 0, 3, 1, 4, 4. Again, important, extend it past those points that you've graphed, put arrows on it. We could go through and label the points, but again, the important part here, whoops, 2, 0. The important part here is if you know where the vertex is, you can find the other points pretty easily. Go over 1, up 1 squared, go over 2, up 2 squared. We can do that to the left. Back 1, up 1 squared, back 2, up 2 squared. So taking a look at these two graphs right here from these functions, if we have y equals f of x plus h, which way do we move the pattern? Left. And if we have x minus h, which way do we move the pattern? We move it to the right. Okay? Now, I want you to also notice these things right here. If I have a function and then I add or subtract something, we figured out that moves it up or down. That makes it a vertical change. If, though, we take the x and add or subtract something before the function makes the shape, that's not a vertical change. We move it to the right or left, so that's a horizontal change. Now, the cool part about this is, even though we've explored a pretty basic function using these ideas, it wouldn't matter how nasty the function is, and you'll see some pretty ugly ones in 1050 and 1060, these same ideas apply. You can tell whether or not the graph's been moved left, right, up, or down just by looking at the function and what's been done to it. When did we apply the change to x or to the function? Okay, are there any questions? Okay. Okay, before we go on, I want to talk about why this does what it does. Okay. That makes the shape, and then we add 1. So all it does is take all the old function values, the ones that used to be here, that's the parent graph right there, and bumps them up 1 unit. That makes the shape, and then we bump all those points down 2 units. So that's what it used to look like. We drop it down 2 units, and we're good to go there. The original one on this one was right here. Adding 1 actually had it make the shape 1 unit sooner. Subtracting 2 has it make the shape 2 units later. Okay? So there are a couple ways to think about this. The reason this shifts it to the left, the negative direction, is because it makes that shape sooner than it would have otherwise. Subtracting 2 kind of slows it down. It makes it 2 units later than it normally would. Does that make sense? The other way to think of it is, what number would you plug in here to make it act like a 0? A 2 here, a negative 1 here. Okay, you could think of it that way also. I like to think of this as make the graph 1 unit sooner. This makes the graph 2 units later. Okay, so let's take a look at a couple of other changes, and these kind of conclude the basic ideas, and then we just kind of apply them from here on out. Okay, what would happen if we plugged in a number, squared it, and then multiplied it by a negative? Yeah, it would make all the answers negative. So it doesn't do anything to a 0. 0 is just a plain old 0. But if we normally go over 1 and up 1 squared, over 2 and up 2 squared, if there's a negative in front, I'm not going to go up, I'm going to go down. I'm going to go over 2 and down. Over 2 and down how far? Down 4. I can go to the left 1, down 1. To the left 2, down 2. Sorry, down 4. Down 2 squared. So it looks like this. Okay, now, I do want to make sure we're all clear on this. When we say you go over 2 or over 1 or over 3 or whatever it is, it's always from the vertex. Okay, watch please. Watch. If I go over 1 and down 1, that puts me right here. If I went over 2 and down 4, that would put me way out here. That's too far. Okay, again, it's always from the vertex. Over 2, down 2 squared. Back 1, down 1 squared. Back 2, down 2 squared. So this point right here is 2, negative 4. Whoops. 1, negative 1. 0, 0. Negative 1, negative 1. And negative 2, negative 4. And if you wanted to plug those into the original function, they'd work. They would make it true. So if we've got y equals negative f of x, then the graph is flipped vertically. In other words, it's flipped across the x-axis. It used to open up like this. We just flipped it downward. Okay, any questions there? Okay, let's take a look at the two of these, because this is where it gets kind of interesting. If I plug in a 0, I get out a 0, and then I multiply it by 2. So what's my answer there? 0. If I plug in a 1, 1 squared is 1, times by 2, my function value is 2. If I plug in a 2, square that, I get 4, times it by 2, I get 8. If I did the same on the other side, here are the 5 key points. 2, 8, negative 2, 8. 1, 2, negative 1, 2. 0, 0. Still has the same vertex, still has the same axis of symmetry. The graph would look something like this. Okay, watch. You don't need to write anything, I just want you to watch. Here's what the original one looked like. Can you see how this one has been stretched to be twice as tall? That's what the 2 does. Instead of going over 2 and up 4, I go up twice as far, so I go up 8. So if I were going to go over 3, how high up would I have to go? 18, because I normally go up 3 squared, which is 9, but the 2 makes me go twice as far. So what this does is it makes the graph, we could say it this way. Watch please, it doesn't do this. It doesn't take the graph and move it in. It takes the points and moves them up. It makes them taller. Points are twice as tall. Or we could say it makes the graph steeper. That would be okay too. So let's look at this one. Plug in a 0, you get out a 0. Plug in a 1, you get 1 times a fourth. 1 times a fourth is a fourth. Plug in a 2, you get a 4, but you're going to multiply that 4 by 1/4. What's 1/4 of 4? 1. Plug in a 3, you'd get 9, times that by a fourth. That would be 9/4, so that would be a little over 2, be 2 1/4. And then the same thing happens on the other side. So it looks like this. And I'm going to label those points really quickly. 0, 0, 1, 1/4, 2, 1, negative 2, 1. Oops. Negative 1, 1/4. Okay. Good there? Okay, watch. Don't have to write. Just watch and think. Here's the shape of the original parabola. We normally go over 1 and up 1, but this 1/4 makes it so we don't go quite as far. We only go 1/4 of 1, which is 1/4. This has been shrunk also. We used to go over 2 and up 4, but now we're going to go 1/4 as far. So we only go up to 1. So if we put a number in front of our function that makes that shape, again, the f of x that we're talking about is x squared. If we put a number in front there, it either vertically stretches or shrinks the graph. What did this do? Okay. Shorter's a better way. Okay, it's 1/4 as tall. 1/4 as tall. This was a vertical shrink. So vertical shrink on this one. You wouldn't want to think of this as getting wider because that's a change in the horizontal direction. Okay, this vertically shrunk it. This vertically stretched it. Okay, any questions? What's the difference between a number that stretches it and a number that shrinks it? Yeah. So if you pick a number that's bigger than 1, it's going to stretch it. It's going to be taller than it used to be, steeper than it used to be. If you pick a number between 0 and 1, it's a fraction, a small number, it's going to make it smaller than it used to be. So let me ask you this. What would this do? Okay, this would be that shape, but upside down. It would look like this, right? Same exact shape, same exact pattern, just be flipped upside down. Okay, are there any questions? Okay, now, I don't want to see any XY tables on your test for this. I don't want to see any XY tables on your quiz for this. You should know what these answers are by the pattern, not by plugging in points, okay? If you continue to rely on points, you're going to get yourself in trouble, okay? Especially when we cover the next chapter. So what we want to notice is, if we change the function after it creates the shape, then it changes it in a vertical direction. There's the function that makes the shape, times it by a negative. All it did was vertically flip it. There's the function that makes a shape, times it by a number. It's going to either vertically stretch it or shrink it. The only thing that changed it horizontally is, notice, inside with the x before we squared to make the shape. So if we've got that set of parentheses there, okay, it's going to change the x before it makes the shape, so it's going to change it in the x direction. In other words, it's going to change it in a horizontal direction. So let's take a look at this right here. All we're doing to this graph is we're adding 2 to it. Do we do it before we square and make the shape, or after we square? After, okay? This is after, so it's a vertical shift. We're going to take that graph and we're going to move it up 2 units. So I'm going to take the parent graph for a parabola, the pattern we're familiar with. It normally is at 0, 0, so I'm going to move it up 2. There's my new vertex. This is the important stuff. This is where we put it all together. From here I go over 1 and up 1 squared. Over 2 and up 2 squared. Once I've got those two, I can go back 1 and up 1 squared, back 2 and up 2 squared. Whoops. There's the right shape. Okay, I'm going to label each one of these. If this is, whoops, 0, 0, it used to be, I moved it up 2, so that's 0, 2. If I go over 2, what's my new x coordinate for this point right here? Well done. Yeah. What's my new x coordinate for this one right here? Okay, new x coordinate is 2 because I went over 2 and then I went up 4, so that would be 6. If I was at 0, 2 and I went back 1, what's my new x coordinate for that point right there? -1. And I went up 1 from 2, so that would be -1, comma 3. Remember, we were at 2, we went up 1, so that would put us at 3. Don't need an XY table for this, but watch. If I plug in a -1, I better get out a 3. Plug a -1 in here, square it, that's 1. Add 2, I get 3. So does it work? Okay. What's this -1 going to do to the graph? Okay, we're going to make the shape, then we're going to move that exact same shape down 1 unit. So it's going to be right here, over 1 up 1 squared, over 2 up 2 squared, so that's going to be up 4, over 1 up 1 squared, over 2 up 2 squared, so it looks like this. See how it's been moved just down 1 unit? Okay, in the interest of time, I'm not going to label those points. Okay, are there any questions? Okay, let's take a look at the next one. Plug a number in. Squaring makes the shape. What does the 3 do to the graph?